quadratic equation. I'm going to have y. No, let's give ourselves a real equation here, not just y. Okay. So I'm going to have 7 is equal to 2x squared minus 5x plus 2. Okay? So I need to complete the square.
That's a 7?
That's a 7 right there.
That was a y.
I was, but then I changed it. Okay. So I'm going to, first I'm going to take my c and I'm going to park it on the other side. So I'm going to subtract 2 from both sides. So I'm going to have 5 is equal to 2x squared minus 5x. And I know that in order to complete the square, this is a mistake that is the most common mistake. In order to complete the square, I have to have a 1 as a coefficient for my x squared. So that means I have to divide both sides of this by 2. So that's going to give me 5 halves plus blank is equal to x squared minus 5 halves x plus blank. Is everybody okay with that? I just divided both sides of the equation by 2, and I put my plus blanks in there because I know that I'm going to complete the square. So I want to complete the square. It's b over 2 squared.
Yeah. So what do you do? It's like a fraction over a fraction?
Yeah.
Well, then you mess with it. Okay. Okay. So I'm going to have that's 5 halves over 2 squared, and 5 halves over 2 is 5 fourths. Okay. So I have 5 fourths squared is equal to 25 sixteenths.
Wait, so sorry, but
Don't be sorry.
do you multiply the 2 and 2, and then you do 5 fourths, then you square that?
Well, so if I have 5 halves, and I'm going to 5 halves, and I want to divide it by 2. 5 halves divided by 2. That's the same thing as 5 halves divided by 2 over 1. And if I want to turn a division problem into a multiplication problem,
Multiply by the reciprocal.
I multiply by the reciprocal. Times 1/2, times 1/2, so that goes away, and that's
But
equal
not
to
the
5
negative reciprocal, right?
fourths. No.
When do you use the negative reciprocal?
When you're doing, when you want to find a line, a slope that's perpendicular.
Oh, yeah,
Okay?
thank you.
Everybody okay? We okay with this? Okay. Let's go back to here. So I'm adding 25 sixteenths to both sides. 25 over 16, 25 over 16. So now I'm going to make this into sixteenths by multiplying it by 8. So I'm going to have 40 sixteenths plus 25 sixteenths is equal to, now the whole purpose for completing the square was to give myself, go from a perfect square trinomial, hang on a second, I might have made a mistake. Did I make a mistake?
No, I did.
You did?
Sorry.
Okay. To a binomial squared, so it's x minus 5 fourths squared. Okay? Okay. So I now have 65 sixteenths is equal to x minus 5 fourths squared.
Is it minus 5 fourths or plus 5 fourths?
It's minus because I had a negative I had a negative 5x up here and it turned into negative 5 halves, so it has to be minus 5 fourths. Okay. So I have so now I can solve this. I can solve this by taking the square root of both sides. Take the square root of that and the square root of that. Don't forget your plus or minus. So now I have x minus 5 fourths is equal to the square root of 65 over 4. I add 5/4 to both sides. So I'm going to have x is equal to 5 plus the square root of 65.
Plus or minus.
Plus or minus, thank you. Thank you very much. Oops. I went off Mr. Jenkins. Okay. So that's how I completed the square, and that's how I solved the problem by completing the square. The purpose of completing the square, a couple things there. One is I could have changed it to vertex form of the equation by completing the square. But in this case, I just wanted to find the solution, and that's how I did it by completing the square. Yes, Julia. Scroll down.
Yeah, I'm confused why it's like this 5. Oh, do the 5/4 cancel out? Oh.
I added 5/4 to both sides.
And then whatever happens to plus or minus?
It's right there, plus or minus square root of 65/4.
Oh, okay.
Oh, should you put the 5/4, like, should you do plus or minus 5/4, or is it plus or minus square root 65/4 plus 4?
Yes, but it doesn't really matter.
Okay.
It's the same thing. It's the same thing. Yeah.
So when you add the 5/4 to the other side.
Yes.
And this 65/4 is 1, so would it be 5 plus 1?
Say that. Say ask.
Because for radical 65 over 4, isn't it 1 radical 65 over 4, so would it be 5 plus 1?
Okay. So what you're asking me here is okay. So you're asking whether or not this is okay. So this is 1 radical 65 over 4. Okay, and then since I'm adding 5/4 to that, is it 5 plus 1 times radical 65? No.
Okay.
It's a fire drill.
Oh.